Lesson 4.1 is on writing equations using symbols. So basically, we're going to be translating words into like math expressions and everything. So we can actually use real life problems, use math to solve real life problems. So just gonna be a bunch of examples in our notes today. So, example 1, Corey bought 2 video games. One game cost $15 more than 2 times the other. Together, the two games cost him $115. So, what I really want us to focus on now is like just pay attention to some hints I give you. These problems can get really wordy, and I want to give you some hints to make it a little bit easier. The first thing you always do if you have to define the variable. So, I'm just going to be using x for all of these. I don't really care what variable you use, but define it. Here's what I mean. He bought 2 video games. One game costs this much more than the other. So I want to let X be the price of one game. Now, I don't always do this next part, but I do find it's helpful sometimes. I know I'm buying 2 games. So I try to break it up like this so I can see which game each game costs. So I'm letting X be the price of one of the games. Now the other one. Now one of the hints I do here, it says one game costs $15 more than 2 times the other. Instead of saying the other video game I've already referred to as X. So if one game costs 15 more than 2 times the other, when they get really wordy, try to like go to the end, kind of where the period is, and then work your way backward. So if I have 2 times X, and then 15 more than that, that's 15 plus 2 times X. 15 more than 2 times the other game, which was X. Now, the 2 games cost 115. So together means add. So now since I have both of these down, I can just go X plus 15 plus 2X, and that has to equal 115. So here's game 1. Here's game 2. Add them together, they cost $115. And we're not solving, we're not doing anything like that in this lesson. We will later. We're just translating, we're just writing equations using symbols. Let's look at another example. Paulo has a certain amount of money. If he spends $6, then he has 1/4 of the original amount left. So again, define the variable. Let X be the amount of money. All right, so we're letting X be the amount of money that he has, or the original amount, or something like that. Probably better ways to write it, but that's okay. So then what I'm going to do is I'm going to say if he spends 6, then he has 1/4 of the original amount left. Well, the original amount we're saying is X. So a lot of times if you cross it out, now we're saying if he spends 6, then he has 1/4 of X. It sounds a little bit easier. So again, work at the end. All right, so again, 1/4 of X, of means to multiply. So 1/4 of X. And if he spends 6, then he has this. Now, is, has, anything like that, that's where our equal sign is happening. If he's spending $6, whatever he has, he's spending 6, that's subtraction. If he spends 6 of his original amount, then he has 1/4 of it left. That's it. Okay, so again, they're going to seem a little weird, but I promise you the more you deal with this stuff, you kind of see the patterns and it becomes easier. Another example. One number is 4 less than another number. The sum of their squares is 208. Guess what we're going to start with? Let X be, and I'm just going to say let X be a number. The number. Okay. And again, I have 2 numbers here. So in this one, I might break it down into 2 numbers. One number is 4 less than another number. All right, so I'm going to say X is that first number. Say that's X, okay? So if one of them is X, the other one is 4 less than. Guys, when you see less than, that means you take this number and put it at the end. Okay, so we've got to be careful with terms like less than. If I have 4 less than 10, I go 10 minus 4. So I'm going to take X minus 4, 4 less than. That's one of those little hints that you need to make sure you pick up at. So I have my two numbers here, the sum, so I know I'm adding them, of their squares. Well, let's square them both. If I square x and I square x minus 4, and then I take the sum, that's our equal sign, 208. All right, so again, the more you can break things down, then you can put them back together in this. Sorry if this video is choppy at all. I'm getting lots of interruptions today. So anyway, so again, break them apart into pieces, and then it's easier to put back together. The next two you want to pay really close attention to because these are going to keep coming back up, and we just have to have some understanding about what they mean. The sum of three consecutive integers is 372. As always, let x, or whatever variable, in this case I'm going to see be the first integer. Okay? Three of them. 1, 2, 3. So x is the first one. Now let's talk about this term consecutive. Like for example, if I had 4, 5, 6, those are three consecutive integers. Consecutive means right in a row. So if this is 4, what do we do to 4 to get 5? We just add 1. So the next consecutive integer, we're just adding 1 to. Here's where it gets a little tricky. We can't just add another 1 to it because we're, again, starting from 4. So what do I do to 4 to get 6? Well, in this case, I add 2. And if it was 4 consecutive integers, you'd add x plus 3. And again, you're going to see this problem come up a bunch. So first integer, second integer, third integer, consecutive. Now we have the sum of them. That means add. So now I'm just going to add them together. X plus 1 plus x plus 2. And there's the word is equals 372. And you can see we have all three of our integers taken care of. Now this next one here is very similar, except you're going to see odd integers. So I'm going to start with let x be the first odd integer. 1, 2, 3. X is the first odd one. So let's give an example of some odd ones. 5, 7, 9. Now this time, the next consecutive odd integer, I'm not adding 1 to, I'm adding 2 to. 2, 2. So I'm going to say this is x plus 2. The next consecutive, I'm going from 5 to 9 in my example here, I'm adding 4 to. So this is x plus 4. If you can kind of see the difference between consecutive integers, consecutive odd, even consecutive evens can be the exact same as this. That's why you identify it as the first odd integer. We want that sum. We add them together. X plus 2 plus, and if you wanted to put parentheses around these, you could. That doesn't hurt anything. When you go to solve them, you take the parentheses out though. Equals 93. So that's why I don't always write them in. But you absolutely can if you want to see the difference. Not really a difference, but you want to see where your three integers occur. In this case, three odd integers. All right, again, the more you practice this, the easier it'll get, but we're really working on translating what we say into math expressions.